Thinking in symbols has always been the most efficient method for creating universal designs. The web pages that we use daily were not created just out of the blue. Rather, all of them went through numerous cycles of prototyping, designing, and user testing before the release. Therefore, implementing smooth and engaging experiences for users is a crucial goal for companies of all sizes. Large organizations and MNCs have the capability and financial power to dedicate entire teams to the design process. But small startups and businesses do not have these resources, and their user experience may suffer as a result. In a usual development environment, the product manager develops the requirements by communicating with the client. Then the designers use those requirements and create variations of mockups and adds the changes manually based on feedback. The developers finally implement those designs into interactive web page prototype. The developers and the time they spend in making the web page more beautiful and interactive, or even sometimes really ugly as seen here, is crucial in determining the quality of user experience. So once the prototype is done, it goes through the feedback cycle again, and finally the product gets shipped to the end users. Therefore, to reduce the dependency on actual web developers for initial prototyping and to enable fast and easier accessibility for non-developers and businesses, our project created a deep learning model which can convert hand-drawn wireframe of a website into corresponding digital web page. From an end user perspective, all the user needs to do is to provide a hand-drawn sketch to the system where the trained DNN model resides. The model will generate the HTML code for the user, on which the user can make further modifications on the fly. Now let's deep dive into the architecture of the model. For training the model, we used an augmented dataset which consisted of an image and its corresponding GUI context. The vision model, built on top of a classic CNN, extracted the features from the input image, and then the GRU-based language model embedded the corresponding GUI context and created a feature map which associated the input image and the context. These models were concatenated and given to a decoder, thus finishing the training part. For sampling, the user only needs to provide a hand-drawn sketch from which the corresponding HTML is generated in no time at all by our model. And look at that! Here we have a live interactive website in our hand. Not the most aesthetically pleasing, I'm sure, but it's good enough for a prototype. For evaluating the model, the most straightforward way is to compare the generated web page with what we had in mind. But still, since we live in a world where quantifiability is essential, we use the BLUE score, which is actually a fancy abbreviation for an algorithm which finds correspondence between machine output and human requirement. And here, in our case, it was done using the generated GUI context and the expected one. As we can see, the model did pretty good with the BLUE score of nearly 97% for an image from the training set, and a score of 71% for an external image which was made shabby and inconsistent purposefully. Although the results are not that groundbreaking, the future scope of the project is huge. The model can be improved further by training with a larger dataset which consists of a wide variety of hand-drawn sketches, which in turn could be generated using modern methods like generative adversarial networks. So in conclusion, the project successfully created a model based on one single vision, that the time required to test an idea should essentially be zero.